A reader of Learning the Art of Electronics recently sent me email and wanted to know why we had to use the SparkFun SerLCD, which is quite expensive, and in fact it's gone up now, it's over $32, instead of an inexpensive LCD display from Amazon or eBay or AliExpress that's well under $10. And I tried to explain that the SerFun LCD is not just the display, it actually has a microcontroller on the back, and if we look on the back, you'll see over here, there's an ATmega 32, that's an Arduino microcontroller, and the reason it has that is rather than using just a parallel interface, which is what this does, this is either a 4-pin or 8-pin parallel interface, the SerLCD allows you to use one of the serial protocols that's typically used with microcontrollers. Microcontrollers can use an old serial protocol called RS-32 or the newer ones, SPI, Serial Peripheral Interface, or I2C, all of which are very common because modern microcontrollers have large numbers of peripherals internal, and they don't have as many pins as you'd like, and if you tried to use parallel interfaces, you run out of pins pretty quickly. Chapter 26 in Learning the Art of Electronics introduces you to the serial protocols inside the microcontroller we're using, the SAMD21. Unlike some microcontrollers which have separate internal peripherals for the different serial protocols, they'll have one peripheral for RS-232, one for SPI, and one for I2C. They may have multiples of each of those. It still limits the number you can use. The SerCom inside the SAMD21 supports all three protocols. So if you've got 5 SerCom peripherals, you can make them all SPI, all I2C, all RS-232, or some mix. That makes them more flexible, but also makes them a bit harder to use. But the downside is they won't talk to a parallel device. Now you can use the parallel device, but you have to use parallel pins, and the purpose of chapter 26 is to teach us how to use the serial protocol. Unfortunately, the SerLCD used to be reasonably priced. Now it's quite expensive. The good news is there's a number of solutions that allow you to put one together that does mostly the same thing for much less money. You can get one that's quite simple for under $10, and if you want one that essentially emulates what this one does, although it will only support the one protocol that we're teaching you, SPI, it might cost you $12 to $15. So let's take a look at how we use this device, and then we'll look at some of the solutions that cost significantly less. In chapter 26, we use the display to display some basic information, teaching us how to use the SerCom, setting it up for SPI, and transmitting to it. And then in chapter 27, we put all the different peripherals we've learned in the microcontroller chapters together to build a complete system. In this case, it's a lullaby jukebox using the SerLCD. And here it is. Our jukebox allows us to enter information. For example, we can select a song, say Itsy Bitsy Spider, and start playing it. And while it's playing, it tells us on the SerLCD what's playing. And it's a little hard to see here, but the backlight is changing. The backlight here is a red, green, blue backlight, and we can combine those to get a bunch of different colors. We can also select another song, here, Teddy Bear's Picnic, put that into the queue, and that will start playing. So we're using this display device as user interface, the keyboard for input, the SerLCD for output. Of course, that means we can't just plug in a parallel device. We need a device with serial input, in this case SPI, and it turns out that we can combine the inexpensive parallel LCD with a microcontroller, in this case an Arduino microcontroller, to get essentially the same function. So let's take a look at how we do that. The easiest SerLCD emulator is to just take an Arduino Uno and an LCD shield, plug them in together, and then connect them up to the microcontroller. So here we have the LCD shield Arduino pair connected up to our Lullaby jukebox. The 2 wires at the bottom are 5 volts power and ground, and the 3 wires at the top are from right to left. The chip select, the data in, which is MOSI, and 1 over from that is the clock. So we've got a dark lettering on light background that's considered a positive display, and you'll see it works just like the SerLCD, except that it's a single color backlight. One thing you'll notice as it plays is there's a flash in the backlight, and that's because the people who designed the LCD shield, and this is true of all of them, use pin 10 of the Arduino to turn the backlight on and off. Pin 10 is also used for the chip select on the SPI, and in Arduino that chip select is fixed. So we are stuck with a flash every time chip select goes low to select the Arduino to send it some information. We get a flash. It's really not that objectionable. It looks very similar to what the backlight is doing on the SerLCD. Okay, here we have another example of an LCD shield. This one I picked up at Micro Center. This works just the same as the one with the yellow-green background. It happens to have a blue background, and it's a negative image, so you have a dark background with white letters. Unlike the previous shield, this doesn't have a set of connectors on the top that allowed us to plug wires into. It does have some holes on the connectors to solder wires to, but unfortunately the connector we need to get to for SPI up at the top doesn't have any holes. Luckily, this shield brings the ISPC connector up to a connector on the shield itself, and the ISPC connector has all the SPI connections except for chip select. So the pin 10 backlight control is poorly designed and always holds pin 10 of the Arduino at a low level, which means that SPI is always enabled. That means we don't have to use chip select. So what we've got are 4 wires. We've got power and ground. We have MOSI, that's data in, and we have S clock. And it works just fine, as you'll see. Because we're not using chip select, we don't get the flashing of the backlight that we had before. So while we don't get a full color backlight, we get a very nice display. This was $8 at Micro Center. I also got a Arduino Uno for $5. So for $13, we have a very nice substitute for the SerLCD, as long as you don't care that you don't have the multicolor backlight.
But what if you want to exactly duplicate the SerLCD even with a multicolor backlight? Well, I was able to find one shield that has a multicolor backlight made by a company called DF Robot. They list it for $12.90. You can buy it direct or from several distributors. There may be some tariffs. I bought mine from Mauser for $12.90, and they tacked on a $3 and something cent tariff. And shipping may be expensive depending on where you are, but it makes for a very nice duplicate of the SerLCD. In fact, I think it looks somewhat better. Let's take a look at it.
So here is the DF Robot LCD shield with an RGB backlight. It's a nice product. It's not well documented, certainly reasonably priced. And what's annoying is we don't have any way of connecting to the I/O pins. However, on the back, there's a bunch of connectors, and if you actually track them down, you can get power, ground, you can get chip select, you can get MOSI, but you can't get S clocks. And without S clock, you can't actually use a SPI connection. What I ended up doing, and it's kind of a pain, is here is the Arduino I used. And this Arduino had a set of holes that allowed me to connect to any of the pins. So I soldered a wire into the S clock, which is right here, and ran it out, and that allows me to connect up. So we'll put these together and see how it looks. Okay, as you can see, one thing that's nice about this display is the characters are actually much larger. The screen size is the same, but the characters expand to fill the screen, and we'll take a look. Also, the backlight seems quite a bit brighter. So all around, I think it's quite a nice replacement for the SerLCD. Larger characters, brighter background, and significantly cheaper. If you can find a cheap Arduino, it's about $20 total, even with the extra cost of the tariff. So there you have it, a complete replacement for the SerLCD that costs about 65% as much. Since the LCD shield with the RGB backlight is relatively difficult to get, another option is to combine an Arduino Nano, which is this small Arduino we see here, which is similar to the Arduino Uno except in a different form factor, with a 2-line by 16 character plain parallel LCD display with a RGB backlight. The advantage here is that these are pretty easy to find. These vary from about $8 to about $12 or $13. They're available on eBay, they're available on Amazon, and a number of other places. They also have the advantage when you buy them on eBay or Amazon, they rarely have a tariff, and oftentimes they have free shipping. If you have Amazon Prime, there's no shipping charge, and a number of the ones that I saw on eBay have no shipping charge. This one came from eBay, and I think it was $9.95. This looks identical to the SerLCD. Actually, the backlight is a bit brighter. The disadvantage of this one is you have to build it. It obviously takes a couple parts, takes some resistors, bypass capacitors. There's a potentiometer here that allows us to adjust the contrast of the display, but otherwise it operates identically to the SerLCD. We connected it up to the Lullaby Jukebox with the same 5 connections. There's ground, VCC, we've got our chip select, our MOSI, that's the data in, and finally S clock. And we can see it work here. And you can see it's very, very similar to the SerLCD. We've also tested this with RGB backlights from Adafruit and Amazon. For the very cheapest version, you can combine the Nano with just a standard single color backlight. This particular Nano was on sale at Micro Center for $5. The single color backlights are often available for, well, depending on where you go, if you're willing to wait several weeks for China, for just a few dollars, but even so, they're quite inexpensive. So here is a reverse LED. We bought this one from Amazon. If you look on the website, you'll see that it was relatively inexpensive. This works fine. There's one caveat, and you'll see what it is in a minute. The RGB has 3 inputs, one for red, one for green, and one for blue, and we turn them on and off to get various colors. The single color only has a single input, which happens to be where the red is. So whenever the output of the SerLCD is set to no red, the backlight on the single color goes blank. There's a simple fix for that. There's a fix in software where you just turn off multicolor backlight. And if you look at the schematic, you'll notice I've always set it up so that there's a jumper. And we can move that jumper so that the backlight's always on. So now if we pick a song, We don't get flashing, and we don't get multicolors, but the backlight's always on. And this gives you the cheapest possible SerLCD emulator without a multicolor backlight. You've got maybe a $5 Arduino and maybe $6 or $7 for the display. If you're willing to go to AliExpress and wait 3 weeks, you can probably get these two for $5 to $8 total. You then have to build it, so it definitely takes more work. But this shows you that there are a lot of different ways to replace the $32 SerLCD.
Complete directions for building any of these versions are available on the Learning the Art of Electronics website, and at the bottom of the SerLCD page is links to the software you load on the Arduino.